Hello and welcome back. We are delving into friend functions today, the counterpart of the last lecture on overloaded operators. So the exercises that we're going to do in this video continue from the previous one on overloading operators. So if you haven't watched that video, you'll need to follow through those exercises, or the first one's not going to make a lot of sense. So exercise 5, which is the first one of this topic, is going to start with modifying the attributes of our star to be private except for the star's name. So to begin, I'm going to grab the code from before. So let's exercise 4 from the last video. I'm going to make 3v friend functions. Paste. And this will be exercise 5. So let's get rid of this. So we have all of our star stuff here. Let's clear this away for now. Well, actually, I can leave it there. It's okay. I'll put the comment at the top. So here's what we're doing. Is we want the attributes of our star to be private. They should not be public. The fact that they are is just because it helped get everything working easily the last exercise. But this is not really good practice. In general, these should be private. They shouldn't be things that other people working with our star should be tinkering with. So let us move it so that down at the bottom here, we have our new private variables. I guess the name is supposed to stay public, so I'll keep that up at above. But brightness and mass will go down there, and now stars just have their name. Now, syntactically, there was no problem with doing that. Public name is up here, private, this stuff is down here, but it will not compile anymore, and let's see why. So, in our operator function for overloading the two arrows here, when we want to send, for instance, things to C out, we have a problem, which is that the function accepts a reference to a star as a parameter, and it is attempting to access the brightness and the mass, but these are private, so we have a problem. We have to figure out how to fix this. Now, one option is you get some getters and setters for these functions, and then we kind of do what we did in one of the previous exercises, but there's a shortcut. And the shortcut is we can declare that this function that prints out the information about the star is a friend of our class. So this function here, copied exactly as it is a friend of the star class. And this friend keyword you can put before any function that you've declared outside of the class, and it means that even though this operator function is not part of our star, and it's not, it's defined separately, it doesn't have the star : thing, it now has permission to access s.brightness and s.mass as though it was a member function. Even though those are private now and we can't access them elsewhere, our friend function does allow us, because we've said it's a friend function, we now are allowed to grab the brightness and the mass. And so now we can compile, everything is happy, and our code does all the same stuff as it did before, and all it took was to write the word friend. So that's it for the exercise 1, really short, and let's try the next one. Okay. Oops, wrong one. Here we go. Okay, let's make a friend function that compares the brightness and mass of two star objects and outputs which one is brighter and which one has more mass. So, I'm just going to rewrite this. Which one has more mass and which one is brighter? Don't mind me just editing the phrasing. All right, duplicate. Exercise 6. So, we're going to make a friend function that compares these two things and outputs. Note that at no point here does it say it returns anything, so this should be a void function. And we'll put it down below here. So it's going to need two star objects and compare some stuff. So since it doesn't return anything, this is a void function, we can say it's compare stars, because that's what it's doing. And it takes two star objects, and we'll pass them again by reference to save on some memory efficiency. We'll have S1 and S2. Okay. Now, if I want to say which one has more mass, I have a shortcut, which is that, if you remember from before, we actually have some operators that will help us compare by mass. So I can do that one first. That one's really easy. If S1 is greater than S2, then I can say S1 dot name is more massive than S2 dot name, else if S2 is greater than S1, do the reverse. S2 is more massive than S1. Otherwise, this one is as massive as S2. They are the same. So this one works nice and clean, and it's kind of obvious how it works because we can just use our comparative operators. I guess to make it consistent, we want to always have S1 first. Then let's make this less massive. And that 2 is always on the right, 1 is always on the left, and we do the comparisons appropriately. And here I need to say if this one is less than this. So this will compare their masses. I also have to compare the brightness. This one, unfortunately, I do have to directly access the brightness of each of the stars. But I can do basically the same thing. So if S1 dot brightness, and basically I have to do this for both of these. And so they're massive, it's bright. Okay, and now let's at the bottom here have a little space, and then we'll compare stars S1 and S2. Let's take a look. Ooh, I got some mistakes. Because I forgot the whole part of the exercise, which was, so first of all, so you notice there's already a problem here, which is that my comparison operator assumes that I'm just getting stars. It doesn't work right now for constant stars, so I need to make sure that that has been changed. Also, the other more significant problem, yeah, okay, same thing. And then finally here, I have forgotten to make this a friend function, so I can't get all the private parts. So let's fix these issues. So issue number 1. Is the problem, let me see here. The problem with the comparison here, for operator greater than, operator types are constant star and constant star. Right. So the thing it doesn't like here is that the comparison between the stars, since I said that they're both constants, the issue is that the versions of the operator overloading that I did last time assume that the right side is a constant star, but the left side isn't. And I would have to write quite a bit more code for that to work. So actually what I'm going to do is I'm going to shorthand this a little bit, and I'm just going to cut const from here. Not best practice. Probably I should overload these operators elsewhere or find another way to handle this, but this should at least get rid of some of the errors, and I'll also get rid of errors by saying that this is a friend function. And now I believe my problem should go away. There they go. So the issues were this was not a friend, which I need to say it is, and also making the first star a constant causes some problems because these all assume that they are not. I suppose I can make them, I think. Yeah, but it'll take quite a bit of coding. So we'll just shorten it and we'll not put the constant here. Not the end of the world, but there are perhaps some ways that you could make this a little better. That being said, now our code should do what we want, which is it will say that Sol is less massive and less bright than Betelgeuse, which makes sense. The brightness and the mass are lower. And similarly, if I compare Betelgeuse to itself, it is as bright and as massive as itself, and that makes sense. And then finally, if I compare S3 and S2, Sol Betelgeuse is more massive and bright than Betelgeuse, which again makes sense. It's 2 stars combined. Okay, so we finished exercise 6. On to the next one. Okay. We're going to make a galaxy class, and our galaxy class is going to have a private vector of star objects, and it's going to overload the subscript operator so that we can access these stars. So let's duplicate. Okay, so down here, let's make our galaxy class. So the class is called galaxy. It is going to have a private vector of star objects. And probably it's best to pass these as pointers just to save on memory rather than having to create a whole new star every time I want to put it in the galaxy. And overloading the subscript operator means I need to be able to grab these things. So we'll call this our stars. Makes sense. Now I need a constructor. My constructor, I think I'll keep it simple. I just won't do anything. But I do need a function to add to our galaxy. So we'll call this add star, given a pointer to a star. And it'll be just as simple as stars.pushback s. And we will also just give our galaxy a name. I think that makes sense. Just so we can refer to it. And we want to overload the subscript operator. So this is our operator. And now we know that when we look at an array and we try to use brackets to access it, we need to give it something. So the parameter for this is actually going to be an index. This is going to give us a star pointer, I believe, because this vector contains star pointers. And it is going to simply return stars.at the index. I'm using .at here as well, just because this will help with any kinds of error detection that might not otherwise appear. Okay, so let's make a galaxy. Let's put our stars in it, and then try to access them. So galaxy g equals galaxy PWA. Oops. G dot add star s1 s2 s3. We'll hold on to s4 for now. Just to see this working, we should probably get a function to display all the stars. So we'll call this display stars. And for here, I think we can just for each, star pointer s in stars. We can say s arrow, and we have something for this, right? Display. Yeah, that sounds good. Display. We also, I think, can just do see out the star. I think that works as well. Okay, let's see if this works. If I have some problems, we'll fix them. Oh, we got lots of problems, so let's see why. Vector does not name a type, and so immediately I know what the problem is. The problem is the computer doesn't know what a vector is, and that's because I forgot the vector library. I will ignore all the other error messages for now, and let's compile again. Okay, cannot convert a star to a star pointer in line 137, so this means I'm doing something wrong here. And I think it's because over here I'm passing stars instead of the addresses of these stars. Let's try that again. Okay, error messages are gone. And it looks like it's not... oh, all right, I'm supposed to display everything. Display stars. See this actually working. What do we got? We got Sol, we got Betelgeuse, and we got Sol Betelgeuse. Hey, everything is there. It looks like I have an extra space in there, so perhaps I want to deal with that. Because right now my display stars seems to be throwing in an extra print. And in fact, I think even here I may have an extra print on top of what I want. But that's okay. We will simply remove this extra one there, and I think that should deal with our spacing issue. Yep, there we go. 1, 2, 3. Okay. So we've got our galaxy. We've got our operator that we are now overloading to return the pointers to these stars, and now we can, work around with our galaxy. All right, one more exercise left. Okay, Exercise 8. Make a cluster class that contains a private array of 1,000 galaxies. Overload the brackets operator to return a galaxy from the array. Then overload the parentheses operator to return the vector of star pointers from, let's say, that galaxy. Okay. So let's get started. Over here. Okay, actually just put this below. So I've defined a star, defined a galaxy, and now let's make our cluster. So our class is called cluster. It is going to have privately an array of galaxies. So here we're going to say galaxy pointer galaxies. Then publicly, I need a cluster constructor, which also is going to probably have a name. There's my name. And in my constructor, I'm going to have galaxies become a newly allocated dynamic array of galaxies, which there are 1,000 of them. Okay. Now, let's overload some operators. So, operator brackets is going to return a galaxy from the array. It's going to need an index to return galaxies index. Our operator here is supposed to take an index as well. And return a vector of star pointers. And here we're going to return galaxies index dot stars. So this is what I want to do, but we're going to see quickly I have a problem. Let's close some of this other stuff. Why do I have a problem? Well, oops, sorry, did I mess this up? No action function called to galaxy. So my galaxy class does not currently have a constructor for when I have no parameters. So I need one of those. So now that fixes the first bug. But I have a second bug, which is that stars is private, and so I need to be able to access that. Well, one option is I can say that this specific function here is a friend function of the star class, but that's really messy. So a much easier thing that I can do is I can say that we have a friend class cluster. And so here I'm declaring to the computer that, hey, there is a class called cluster. It is a friend, which means it's allowed to access the private attributes. Oh, did I mess this up? I think I wrote it properly. Improperly, I should say. Galaxy stars. Oh, sorry, it's the wrong thing. It's not the stars that's supposed to be the friend. It's the galaxy should have clusters as a friend. So friend class galaxy. There we go. Sorry, friend class cluster. Making every mistake in the book here. Implicitly friends with itself because I typed the wrong thing. And look, our error is gone. And so all I had to do was tell the computer that, hey, clusters are friends of galaxies, which means that our friend cluster class can actually access this private stars variable when normally it could not. Now, most of what we have here looks like it should do what we want. Sorry, down here. Let's test it out. So right now I have one galaxy, it's just a Milky Way. Let's do a second one. We'll call this one Milky Way 2, just for fun. Actually, no, let's call it, I don't know any names of galaxies. That's Andromeda, is that a galaxy? I don't remember. I think it's not. Is Andromeda? Yeah, it's a galaxy. Okay, I'm second guessing myself here on things. Okay, and we'll add S4 to it for fun. And then we'll call this G2. And this is G1. Okay, so I got my two galaxies. Now let's put them in our cluster. So to do that, I want to, so I have my dynamically allocated array of galaxies in my cluster. So let's say cluster C equals cluster, my cluster. I don't know the name of our galaxy cluster. Is there a name for it? Let's see. The Virgo supercluster? Sure, we'll call it Virgo then. Virgo cluster. Okay, so we got the Virgo cluster. And here I want to say C0 is G1, C1 is G2, and then let's start by seeing if I can access C0, that should be our first galaxy, and do display stars. Or I should be able to, yeah, let's do display stars. There's so much stuff being printed out. I think I want to clear some of the displays here. So let's clear up a bunch of the display stuff. Clear these couts, clear these couts, and displays. Okay. Clear. Compile. Go. Okay, so oops, we still have some stuff left, I think. Compare stars is still here. Let's get rid of that too. And so now I'm printing out nothing. But I have a problem, is that I should have been printing out display stars. So what happened? Well, if you want to know what happened, the secret is to do with this function here, which looks totally right, and it seems like everything is okay, but there is a problem going on here, which is, what is galaxy's index? Well, our galaxies are supposed to contain the different galaxies here, Milky Way and Andromeda. They've got the stars inside of them, but it seems like this galaxy doesn't have anything in it. What's the deal with that? Well, let's see what other functions we have here that we can maybe work with. What happens if maybe we try adding a star to C0? Will it show that one? Let's see. C0 dot add star. Let's try to give it S1. Why not? Seems like nothing has happened. And this may be very difficult to debug, if not for the fact that I already know the problem, which is the return type of this is wrong. When I'm accessing data from an array, I don't want a copy of the data that's being managed here. If you look at this function is a pass by value function that's giving us a value back. And the value it's giving us back and forth is just going to be copies of the data that we're working with. And so when I start by saying C0 equals G1, this piece of code actually is doing basically nothing, because when I go to access C0, it gives me a copy of this empty galaxy that I made, and it gives us that empty galaxy. Okay, and so now an empty galaxy is G1, but this isn't actually putting G1 into my array because I'm not referencing the array. To fix this, I need to make sure I am using a reference to a galaxy instead, and that's what I want to be dealing with. And now suddenly, things are happening. I can actually put stuff in here. I think I had, what was it? G1 was Milky Way. And those are the things I'm displaying. And now if I do, for instance, C0 dot add star, let's say I add S4, now I should see 4 stars. Those are my 4 stars. So very, very subtle difference where a single missing ampersand, somewhere we actually haven't typically seen this before, which is as a return type, completely changes how our program behaves. Lastly, let's make sure that this gives us our vector of star pointers, although I think it should do that. So for star S in, And I think we want to go with, so let's grab the stars in our second cluster, G2. So in cluster parenthesis 1. So for each pointer to a star in basically G2, which should only have the one star, let us output the star. So we now have a pointer to a star, so we should be able to say S arrow. I can actually just output S. Let's see, sorry, dereferenced S. Yes, we're good. And I think, yeah, that's S4 showing up a second time. Here, let's make it a little cleaner here. Add a space. Run it one more time. Clear this up. And we got our first galaxy right here. Probably be nice, actually, just something to clean this up would be good to print the galaxy name at the top here to mention this is a galaxy. And then here we actually just have our star showing up. Okay, so we've done a little bit of experimentation, a few new things, new little tricks that show up here that can easily lead you astray if you're not used to them. Making sure we're returning a reference to a galaxy here and not just a galaxy. In order to access these stars, we needed to declare cluster as a friend class. And I think that was it for this exercise. But you can see that we've expanded our stars quite a bit from our last set of exercises. But now it allows us to do some very clever things that we couldn't do easily before. So that wraps up for this video. Thanks for watching, and I will see you around.